Hello, Internet, and thank you very much for listening to us on the today's episode on Cloud Native FM podcast. My name is Saim Savdur, and I am the co-host of this show. And let me give you insights what we are covering today. I hope the topic we are covering today will give you the wonderful insights because I see a lot of debate happening in this era around platform engineering, build versus buy model. So let me give you this quick intro what we are covering today. As the title suggest, we are decoding platform engineering, build versus buy dilemma. So, platform engineering, we know, plays a crucial role in designing, building, and maintaining the platforms that enable efficient and scalable software development and operations. But there are response possibilities where could message go possibly wrong in platform engineering hype. In this episode, we unravel the complexities that platform engineering teams face when deciding between buying pre-built solution and building custom in-house platform. Join me in welcoming Rhea Arora from Developer Relations at Miaplatform and Michelle Murabito, Developer Advocate of Miaplatform, as we engage for an enriching episode on the buy versus build dilemma in platform engineering and gain a clear vision and embark on a path that align with your organization goal. So without any further delay, let me straight to my guest, Rhea and Mitch. Thank you
Hi.
very much for joining us. And let's start with Mitch first. Can you give us a quick intro of yourself? We are busy these days.
Okay. First of all, thanks for the invite. Together with Rhea, we work at Mia. At the end, I am a developer advocate. I'm spend all the day and all the life, let me say, with community and conferences. I'm live in Italy, in Milan, for let me say for now. And yeah, that's it about me. I love community. I love to stay with people, talk. And so on.
Thanks, Mitch. And
Perfect.
now it is straight to Rhea.
Thanks, Saim. Hi, everyone. I'm Ria, and I currently live in London and work in developer relations at Mia Platform. I am originally from India, but I've been living in London for the last 2 years. Unlike Mitch, I don't have that much experience in this space, even though he is the expert. But I'm trying to follow in his footsteps, and I'm here today. And thank you, Saim, for having us.
Yes, thank you very much for giving your intro. Let's start the agenda first, and I can ask few of the question by starting about the first of the question. I think a lot of the people who are listening to us, they have their mind. What is the current state of the development? Because there's a volatile market, there is so much tools available. We can refer to as in the CNCF landscape. Over to you, Rias. You can actually share your insight around it.
Thank you, Sam. So, yes, I'd like to start this part by maybe talking a little bit about the technology landscape today. So, as we know, the technology landscape, it's constantly evolving, right? And there are new tools, frameworks being developed to address various challenges in software development. These challenges are in cloud infrastructure and data management as well. And this includes tools like Docker, Kubernetes, AWS Lambda, and in general, serverless tools, along with CI/CD pipelines. What developers and DevOps teams are continually exploring and adopting these tools to streamline development processes, enhance scalability, improve security, and reduce operational overhead. The rise of microservices architecture has also driven the need for tools that enable seamless communication and coordination between various microservices. As we speak about cloud native services, we can also discuss, as you mentioned, CNCF, which is the Cloud Native Computing Foundation. So CNCF, as everyone here knows, I'm sure, was founded in 2015, and it's a vendor-neutral organization that aims to promote and foster the adoption of cloud-native technologies. So it hosts a vast ecosystem of open source projects, including some popular ones that we know, like Kubernetes, Prometheus, Envoy, and a lot more. These projects, they cover various aspects of cloud native computing, right? Such as container runtime, service mesh, logging, monitoring, and many more. So as the CNCF landscape continues to grow, some tools are added to it, and then some of the tools that are there, they're constantly changing and upgrading over time. As this happens, it becomes essential for organizations to navigate this vast ecosystem effectively and in a way that will help their organization. So, CNCF projects are often the foundation for cloud native applications, and understanding their capabilities and integration points is extremely crucial for modern software development and infrastructure management. So, in today's fast paced tech landscape, the problem that most startups face is the challenge of selecting the right tools from the CNCF ecosystem. So, when you talk about tools, we have so many options for different tasks, right? So, if we take an example of maybe API gateways, so if you're finding the perfect fit, it can become quite overwhelming for the team, and it also takes a lot of time. Sometimes you may start from scratch and it may seem like that's the best option for you, but then it makes software reuse a challenge, and you end up spending a lot of time on that. Now, don't get me wrong, of course, it depends. Sometimes starting from scratch might be the best option for you, and we will look into this a bit later in the conversation. So, the market basically demands change really rapidly, right? And for startups to keep up with this shift is extremely important. They need to be agile and they need to be able to integrate existing systems seamlessly into their system to stay competitive. However, this can be a daunting task for them and it could delay their time to market. So, this is where platform engineering that we all talk about comes in, and it's a valuable solution for everyone. It could, in many situations, offer you an ecosystem with tools and configurations that allow startups to focus on their core business need without getting bogged down by complex setup requirements, etc. So, platform engineering basically gives companies the flexibility to easily choose and switch between different tools, such as mentioned before in API gateways, like we use that example, based on the company's strategy and needs.
Thanks, Rhea, for the wonderful insights. Let me think about and hope I can actually conclude in a good summary. So basically, you have to stay updated with the industry trends and leverage community-supported tools and evaluate tool maturity and stability. Embrace interoperability and standardization. Conduct thorough evaluation. Foster a culture of experiment. The key is to carefully evaluate, experiment, and adopt to the changing development landscape based on your organization's specific needs and goal, and regularly reassess your tooling choices to ensure they align with market trends, industry best practices, and long-term development strategies. So we talk about CNCF landscape, and we saw there's opportunity of the platform engineering. Can you, Ria, tell my audience what do you think the platform engineering is, and what it is, and what its benefits?
Yes, of course. Thank you. So let's begin with what's platform engineering really all about. So it's a practice of creating a robust and scalable foundation or platform that enables efficient software development, integration, and deployment. So it aims to simplify complex technical tasks, accelerate development processes, and facilitate the seamless integration of different technologies, ultimately empowering the developers to focus on building high quality applications and services and leaving out all of the repetitive tasks that are already pre existing. So, platform engineering, it encompasses various aspects. It encompasses creating and managing containerized environments, setting up continuous integration and continuous deployment, and also helping you implement automated testing and ensuring efficient monitoring and logging. So the platform serves as a stable and consistent environment for developers to build, test, and deploy their code. It establishes best practices, guidelines, and common patterns that ensure consistency across different projects, but also, more importantly, different teams and different people. This, I think, is one of the most important facets of platform engineering. By creating this standardized foundation, what platform engineering promotes is collaboration. It enables faster onboarding of new team members and reduces the time spent on repetitive setup tasks.
Yes, absolutely. That's cute. That's a neat way and the clean way to think about platform engineering is. And I think I had a chat with Alexis Richardson from the WeWork team, and I think one of the definition he coined is really actually set the lights how we think about platform engineering is. During the episode, he shared Like platform engineering is how we simplify computing for every developer within your organization by creating environment for them to run their apps. Those environments become the platform, and the job of the platform team is to choose where they're built, where they run, and make sure they are always available in an easy way, and separating those concerns between the automated platform and app dev who have an easy time. That is platform engineering. And the episode is, I think, episode number 81. You can watch it on the same channel as well. So next question is, what were the deriving factor that led to the emergence of platform engineering as a distinct discipline within software development? Over to you, Ria, again.
Thank you. So for sure, there's a lot of factors that led to the emergence of platform engineering. I'll get into a few of them, but it basically, the first one is the rapid pace of the market. So the demand in the market, it demanded faster delivery of software functionalities and business requirements. Without platform engineering, developers spent a significant time configuring various tools, slowing down the entire development process. Moving on, if we talk about one of the second reasons, is the shift to microservices in large companies. This led to multiple teams working in parallel with different languages and approaches, leading to duplicated efforts and also inefficiencies. What this really means is, in such a large team that's building multiple projects at once, there may be quite a few lapses in what they're building, and there may be a lot of common code that they might be using. And not being able to kind of see and reuse this code may cause some sort of duplication and duplicated efforts. Moving on to the one of the third reasons is centralizing technology, information, and documentation was very challenging and expensive, making it difficult for developers to access critical resources that they might need. Lastly, onboarding new employees required extensive tutoring and having them understand the company's complex platforms and find relevant documentation, which can also end up taking some time. So, in response to these challenges, platform engineering emerged to simplify developer work, to streamline processes, to foster collaboration, and provide a cohesive foundation, like kind of a superhero toolkit, you could say, to enhance software development, efficiency, and effectiveness.
Thanks, Rhea. That's a solid reason to think about why we're actually talking about platform engineering and what the hype was. I think, like I discussed with Alexis Richardson on episode number 81, he mentioned there are some the advent of cloud computing, infrastructure as code, DevOps, continuous delivery, increased complexity and scale, need for standardization and efficiency, and with the growing importance of observability and monitoring, and the rise of containerization technologies like Docker and like Kubernetes contributed to the need of the platform engineering. And what do you think people like? What do you think about why this emergence field actually exists today? Do let me know in the chat as well. But now I will actually circle back our conversation to Mitch, and we talk about and Mitch, like the question number one in the domains of architecture and design consideration for platform engineering teams. How do you approach designing a scalable and resilient platform architecture that can handle increased user demand and growth over time? Over to you, Mitch, now.
Okay, as with every innovation, it all starts with people. Okay, this discussion need to start with people, person, teams, and so on. If we talk about platform engineering, we can imagine three different entities like teams or people inside a project. This kind of team are the platform engineering team, of course, and the second one is the contributors team, and the last one is the consumer. Let me say that we can imagine the platform engineering like a very big open source company that we have some people that produce new functionality, some people that manage to merge the work of the people and so on, and other people that use this functionality to create new stuff. When we talk about platform engineering, we need to talk about, for sure, the organization, because it's a very important part of the discussion. Let me say an example. When maybe if you or the listener work as a developer, they know that a lot of time we need to reinvent the wheel. For example, for the login, just a simple stuff. People need a login in an application. After that, start with analysis about the functionality, choose the right tool, implement it, and so on. And in the next time, or another team in the company need to do the same stuff, and after that start to do the analysis. After that, implement the solution, test the solutions, and after that they have again the same functionality for the same time for the second let me say yeah, they have the same functionality but with 2 time of work about that. When we talk about platform engineering, we need to talk about flexible system. For example, as Rhea pointed out, many new tools emerged every day in the landscape, but also not in the landscape, because the landscape is a very small part about the technology around the world. And of course, this technology evolved during the time, and it's very great because a team of producer can start to work on a plugin or a functionality, and they can provide this functionality for other teams. At the end, the platform engineering team role, it's very easy because they need to automatize all the stuff and to be sure that the functionality are sure and respect the guidelines and so on. But it's very useful for the company because the company in this way can start to build a set of plugins, a set of functionality, and after that they use it. Of course, when we talk about this kind of organization, we need to be sure that when a team start to work on a plugin and after that start to update the plugin for new versions, new functionality, they need to be sure that this functionality is stable and work for the team, for all the team, not just for one team. And I think it's very important to understand this part about platform engineering, because a lot of people talk about technology, and of course it's also part of technology. But I think the majority of the problem is about the people. We need to understand that is very important to be focused on people.
Thanks, Mitch. Let me conclude. I hope I can conclude it in a good way. So, I believe that horizontal scalability is achieved through a deployment of multiple instances of your application and service, allowing you to distribute the workload across different nodes or container. And this ensure that as user demand increases, we can dynamically add more resources to handle the load and achieving optimal performance without any service interruption, and prioritize continuous integration and continuous deployment practices to ensure rapid, reliable, and safe updates to your platform. Monitoring and observability play a vital role in maintaining a resilient platform. Integrate robust monitoring tool to gain insight into the system health and performance. And this proactive approach allows you to detect anomalies, bottlenecks, and performance degradation, allowing you to take timely corrective action and prevent service disruption when it's come to scaling or designing a scalable and resilient platform architecture that can handle increased demand with the growth of the time. So the next question is for, once again, for the Michelle, is what are the key consideration when it comes to selecting technologies, framework, and tool for your platform engineering architecture? And how do you evaluate and choose the right one?
Okay, before continues, I want to be a very short clarification because I talk about feature, about, let me say, plugins. But when we talk about platform engineering, we talk also about infrastructure, deployment, and a lot of other stuff like documentation, testings, and so on. When I talk about functionality, it's just for example. Okay, about the question, I think that depends. From scratch, you need to pay a lot of attention to, let me say, do the right choose. An idea can be start this kind of challenge with a small pot with a couple of functionality, and after that, try to improve this functionality and increase that. But if the platform isn't your core business, I think that pay it remain the best, let me say, solution. Okay, about the functionality, I want to explain my opinion with three different steps. The first question, when you want to add a new, let me say, functionality in your system, the first question is the tool is easy to integrate into my system because a lot of time we want to add a lot of integration, new functionality, we want to support new providers and so on. But in a couple of cases, this kind of adding can be easy. And of course, the platform need to be stable. For this reason, the first question, of course, it's this kind of solution can be integrated. About the second point, from my point of view, it's about the tool. Maybe you can build your functionality from scratch, you can use third-party software like open source or other tool from other company, let me say vendors. About this part, if the software isn't your, my second question is the tool it's maintained and in case of a problem or a very priority bugs or so on, I can ask for paid support because a lot of time we, let me say, don't think about that, and it's very problematic stuff because, of course, if you have a platform and you base your platform with a plugin or with a functionality or a platform, and sometimes you can have problems with this kind of functionality, and the problems maybe in a plugin can be a problem to a whole platform. Having a paid support can be let me say very important for the solution. And the last one, it's the last one, but I think it's the first one. It's do I need the tool? Because a lot of time I see a lot of product projects and so on that the people start to include functionality, a lot of functionality, and no one uses it. They just choose that this kind of functionality is useful for the platform. They start to including it in the platform, and after months or years, they understand that the functionality is never used from anyone. And I think it's very important to try to understand this aspect. Of course, when we talk about including a functionality from scratch, we need, in any case, to evaluate the cost, the benefit, and the risk to try and start to develop a functionality from scratch.
Thanks, Mish, for wonderful insight around this question. So I think like right now is if you look at the if you look at the ecosystem, you have to assess the business objective and requirement, meaning you start by understanding your organization specific business objective and platform requirement, and then identify the specific challenges you aim to address, the scalability needed, and any unique feature required for your platform. Scalability and performance assesses the scalability and performance capability of the technologies and tool are considering. Look for solution that can handle current and future growth as well as accommodate spikes in demand. So I think the structured approach is kind of very important here, and consider these consideration. You can confidently select technologies, framework, and tool that form a solid foundation to for your platform engineering architecture enabling you to build scalable, robust, and successful platform. So the next question is really important because I'm working on the platform CNCF platform working paper as well. I can share the link on the screens now. So, and one of the things we're working on is how to approach forward thinking with platform engineering. So the question now become in general, how do you address the challenges of platform evolution and backward compatibility?
Okay, it's a very hard question. Maybe we will use an hour just for this one, but I try to resume it in a in a couple of minutes. Okay, first suggestion. I think it's common sense. It's use standards because I see a lot of companies, a lot of organizations start to create stuff. But my suggestion is doesn't reinvent anything. The idea is to use standard configuration, for example, standard communication protocol, and so on. It is typical when you want to create stuff that someone say, but I don't like this protocol because I want to use my very incredible standard. But at the end, let me say, isn't a standard. I start to write code, I think like 20 years ago. And when I started a very big company with a browser, for each version of the browser start to include a new standard, and this standard browsers. Okay, it's a crazy stuff because, of course, if you start to use the standard, maybe you can add the new functionality to your system without pay a lot of time creating, for example, conversion about protocols, standard formats, and so on. I think the first one it's about common sense. Another suggestion is about the updates. Okay, maybe we can talk about Kubernetes, but it's just an example. We can do the same discussion with each software, each cloud provider, each provider, and so on. When you use a software like Kubernetes, maybe you use a version of Kubernetes, and a couple of months ago there is a new version. This version is 100% compatible with your system, and you say, okay, maybe for remove this to update, I don't update this version because for me it's more easy stay in my version, in my old version, and don't change nothing. I think it's a very critical error because in this way your software version are very old, and when the version of your software is very old, maybe you can have in the future a lot of problems to update it. My suggestion in this case is update anytime. If you don't need the new version, the new functionality, try to update it because, of course, you have more, let me say, you are more secure about the issues. You can maybe use new functionality without problems, and I think it's a good way. In this way, when you update your software each a couple of months with new versions of your requirements, let me say your software requirements or prerequisite software, when a software like Kubernetes introduce a breaking change and you need to update it because maybe it's mandatory for security reason or other reason, you are more ready to update it. And I think it's very important. And the last one is about the standard and the communication about services and about piece of your software. I think the good stuff at this moment is use standard tool of integration, standard protocol of communication. For example, if you have a system of microservices, the right way to communicate between systems are APIs at this moment. And it's very important to create your software with this kind of integration. And when you create this kind of integration, you need to create also the documentation to, let me say, document anything inside your system. If you use an approach like platform engineering, you can, of course, save time for the time to market, for example, removing the repetitive task and so on. Maybe you can allocate part of this time to write the right documentation, the right information to provide to your colleagues the right tools to maintain all the stuff during the time.
Thanks, Mitch, for wonderful insight. I think that's a very, very important question right now for all of the organization because as you move with the platform, and there is, if you look at the CNCF landscape, it's had so much tools, monitoring, observability, service message, GitOps, and when you start building the solution, you have one tool today. And as you move forward with this approach, like, do I need an ingress controller? Which one I choose? I need a service mesh. Which one I choose? I need a GitOps, Argo CD or Flux, monitoring observability, plethora of tool. So I think this is a hugely a debate right now how we actually go about with the platform approaches. So the next question I can ask you, and I think that's a considerably similar to the first one, is how do platform engineering team collaborate within the team, such as product management, software development, to ensure alignment and a shared vision for future platform announcement for the future. Over to you, Mish.
Okay, just another clarification to the previous question because I think it's very important. If you use standard and common communication protocols in the example of ingress, maybe you can remove your ingress and add another ingress without a lot of effort. And I think this is very important. About the question, let me say introduce the answer with a couple of sentences. There is two type of necessity, okay? The real priority necessity and the others, okay? Keep in mind about business requirement, cost, and risk. I think when we talk with other people in the company, it's very important to understand this principle because, of course, we want to develop our platform just in 2 days with 1,000 of different functionality, but this is this isn't possible because no one can stay updated to all the necessity in the company. You need to create prioritization about the functionality, and for do that, you need as a platform engineering team, because we talk about a platform, you need to talk with all the team in the company. You need to understand all the necessity, all the requirement for each functionality, and after that you need to understand which functionality are need to insert in the roadmap because sometime let me say you use a FIFO approach, first in first out. Someone asks you a new functionality, you don't have work at this time, and you start to develop this functionality, and I think it's very wrong doing this way. The real approach and the good approach is talk with people, talk with the teams, after that understand the necessity, maybe talk with the C-level, the managers, to understand which functionality and which priority insert in your software. And after that, maybe you can start to create a roadmap. But in any case, you need to keep in mind, of course, business requirement. We already talked about it, the cost about the functionality, and the risk to introduce it in, let me say, in your platform. Let me say, in this example, the platform engineering team, there is like a conductor of an orchestra. They need to understand all the necessity from different team, and after that, choose the right roadmap for all the company. In any case, Okay, some people say to me, but it's a limitation because maybe some team can't explain the necessity, or some functionality are included later after this analysis, and how in this case we can manage the situation. We already responded to this question at the beginning of this discussion, and all the stuff can work as a contributing and let me say contributors and maintenance of software, including the platform. If my team need a new functionality and the platform engineering team can add it to the platform, I'm in this case responsible to start to write this new functionality. Okay. After that, I can propose this functionality to be included in the product, in the platform, and the platform engineering team can help me to include this functionality. At the end, let me say it's very important because when you work in a very large company, you need also to have flexibility, and let me say you need to allow the people to create stuff. And in this case, I think it's very, very crucial in an organization have for sure strict rules about components and what they need to include. It's very important to create a roadmap, but it's very, very important also to have flexibility.
Yes, absolutely, absolutely. I think that you explain it wonderfully well, because I think right now, if you look at the ecosystem is developing, organizing the team is a challenge, because there's a new role in the horizon. We have software engineer, we have platform engineer, we have a SRE, we have DevOps, and now people thinking about there's a new team in coming up. That's we called platform team. So by making a platform team, that do we really need a DevOps engineer, or its DevOps is completely is out of the market? So that is really where the misconception alignment is happening. And I think like if you there's some article mentioning how the different roles work within the different organization. And I recently learned a wonderful platform paper called How Platform Team Gets Stuff Done by the Martin Follower. And I think they really align it perfectly well, how different team works together. And one of the really the shining point of this article is they mentioned that the platform team should be careful to not open up their code bases to external contribution without making some thoughtful investment to support those contribution. And there can be a deep frustration all around if a platform team proudly in all hands that their code base is shared resource, but then find themselves repeatedly telling contributor from other team, oh no, 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 it's not like that. So I think the key takeaway from this conversation is a platform team succeeds on the back of collaboration with other team, and that collaboration can take many forms. Choosing the right form involves considering the type of platform work other teams are doing. So that's really a pivotal point here is. And now we have run short of time, but I'll ask few questions right now. That is wonderful. Number one is, what metrics or success stories can be used to demonstrate the benefit of standardized Kubernetes deployment? Over
Okay.
to you.
Oh, yeah. Also, in this case, it's let me say, in our work, the right response it depend. Okay. At the end, the key metrics can change a lot. In our industry, at the end, we often say it depends. Let me say a couple of examples. For a manager, maybe you can use some metrics for the developers, for the developing. For example, the manager can evaluate the time to market from the beginning of a development to put in production a new functionality. Or maybe can, let me say, for a manager can be important have statistics to the delays accumulated in the development process. Maybe the efficiencies of calculation and the infrastructure cost and so on. For the developer, maybe there is other metrics. Maybe the developer want to know the deployment frequency, time to obtain a new environment. We don't talk about a couple of strange situations. For example, a couple of weeks ago, a friend said to me, this period I don't work a lot because I need a new environment to test a new functionality, and I open a ticket, and after that I wait 3 days for this environment. This is incredible because you have a developer that not working for 3 days for a ticket. Okay, with platform engineering, you can solve this kind of problem because maybe you have a self-service platform, you can click just a button, and after 10 seconds, you can have your environment. And for a developer, this kind of metrics, it's very important. For example, the time to obtain a new environment. Of course, the reduction of time spent in sideline activities, because maybe you don't like to have repetitive task and to wait stuff. Okay. When we talk about platform engineering for the developers, maybe we can talk about developer experience or this kind of stuff. I think at the end that each people in the company need to have different metrics. For the management, maybe a good metrics to demonstrate the efficiency of the platform engineering can be about saving money. For example, if you have a platform and inside this platform you can include system to look at the cost of the infrastructure, to reduce the cost of the infrastructure, maybe this kind of metrics can be more useful for the management. For a developer, maybe can be the time for onboarding new people and so on. And at the end, I think the right response in any case, it's depends.
Absolutely. And if you look at, if I think the listener who are listening to us is, if you are using the Kubernetes or outside the Kubernetes infrastructure, I think if you go back in time, I talk a lot about when I'm speaking in public, like if you live in the virtualization era, and I ask a lot of the people the same question, like how many of the people who are listening to us, they are spinning up infrastructure by yourself? One of you, two of you? I think the question is none of you. Nobody's actually spinning up infrastructure by hand in the cloud or creating a virtual machine. Nobody's doing that. We love it. I think if you go back in 2010, everybody is doing and spinning up the infrastructure, and all the nerdy people are doing these kind of activities. But right now, nobody doing it. It's all about Terraform, 5 lines of the Terraform, and this virtual machine is spun up in Linux install, and apps are deployed, and then your application is working, and end user is interacting outside the world. Now you ask the same question: how many of you are actually running Kubernetes locally? One of you? I think today might be 100 of you or 1,000 of you. But going down the road, I think 10 or 20 of the you who are already nerdy people or letting people know how to work with Kubernetes, spinning a Kubernetes by hand. Otherwise, this Kubernetes become abstracted and nobody's using. It's going to be the same thing that happened to the cloud. And that's where the platform engineering and IDP stories is, might be the message is kind of a two-way, but in theory they are telling the same thing, that the developer job is to build revenue for the business. Is not the job for the developer to create Kubernetes cluster locally. Otherwise there is so much of the wastage of the time. This is not your job. Let's You need a platform, click on it, Kubernetes install, service mesh install, and then you start doing your work. This is not your job. So basically, I think that's where the momentum is going forward, and you phrase it perfectly well. So I think the questioning is more oriented toward these days is, like, we know Kubernetes become abstracted, but who is the team who is working with Kubernetes? Is it a DevOps, platform engineering, or is it like developer who is interacting with Kubernetes, how the organization standards work. That is kind of the story is actually is going forward. So, but I've asked few of the question, and I think the few the very important question, and then a span of the today's episode is number one is I think that's really important for the people who wanted to learn. And I will circle back conversation to the Rhea again. Is can you tell us like what is the decision between building product and buying them and weighing off the trade-off? Because I think that's a really important question of today's topic.
Yes, of course. Thank you, Simon. This is an interesting topic, and it depends is always the answer. But to give you a few points for that, so building an IDP solution from scratch can be challenging as it requires careful step-by-step development and can be quite expensive. So opting for a ready-to-use IDP solution offers significant advantages, I think, because it helps you save time and effort in building and managing a platform, and existing IDPs come packed with a wealth of functionalities, plugins, connectors. So you can literally start from day zero. There's no time in between, right? It makes it easy to integrate with various services. For example, Miaplatform is an IDP builder that provides a comprehensive set of tools and functionalities supporting multiple cloud providers, Git repositories, and pipeline runners, simplifying the entire process significantly. However, on the other side, if you look at this, if you need a highly personalized internal developer portal, then it has if it you need it to be tailorized to your specific needs, then building an internal IDP might be a better fit for you because it may allow you to customize every aspect of the IDP according to your requirements, providing like a perfect solution for your product. So the trade-off basically that you have to weigh is building an internal IDP requires time, effort, skills, ongoing maintenance, and is also a burden for developers. And in many cases, it's not really worth it if it's not part of your business, but just a tool for you to do your business. On the other hand, having a ready-to-use IDP offers instant solutions with low time to market, updates are automatically provided by the IDP creators, and continuously improving technologies and features are present. So the variety of features allows you to choose and utilize the functionalities that you need without the hassle of building them all from scratch. Of course, if you buy an IDP as well, there is a way to still have custom functionality. It's not as easy as having your own IDP, but there can be a way to start very fast and then integrate new functionalities. So ultimately, the decision to buy or build an IDP depends on your specific requirements, your budget, skills, and your timeline.
Absolutely, phrase it wonderfully well, Ray. Absolutely, absolutely. I think this is the conversation becomes more and more in the market right now because if you look at this virtualization era, the same debate happening at that time. Do I create a team of 10 individual whose job is to spun up infrastructure in the cloud, or do I have to pay a subscription from AWS that
Yeah.
give us a ready-made infrastructure, and that's one click installer infrastructure. And that's debate is now actually circling back after the decade again in this space. Like now we're talking about, do we need a team that's whole responsibility of 10 to 20 people just doing
Yep.
a Kubernetes cluster spun up, and then their job is to actually help development team to be a self-service? Or either we can bring or buy a IDP that has pre-packaged, pre-built-in capabilities, and then their developer is actually self-service. They don't need to file a ticket for the DevOps team. Please create a ticket for me so I can join you. So that is actually, I think the circle is going to happen. It's sometime I think the buy is a good option. I think if today is people are working or in reinventing the wheel, but tomorrow they don't because the pre-existing solution can be a good fit. And here's a website link for you if you wanted to learn more about Mia and how it can help you become more self-service. So would love to spend more time with Mitch and Rhea on another because this is a conversation we can talk all day. But we have to conclude in some way. Number one, Mitch, you can tell us some of the resources and some of the work you actually already been doing in the Mia platform to help developers self-service. And next, you have to conclude for the audience what are the best way to go forward with this approach. Mitch, can you unmute yourself?
Of course, sorry. About the resources, of course, we have a blog in Miaplatform. You can find it with blog.miaplatform.eu. It's let me say a vendor neutral blog. We don't talk a lot of about Miaplatform, but we talk about platform engineering in general, and there is a lot of materials. Another very interesting resources, if you are a developer, we have also GitHub. You can find Miaplatform organization in GitHub. We have a lot of templates ready to use, and of course, you can use it without any kind of problem. And another important stuff, we have 3 different open source projects. KubeGreen, maybe you know, it's a kubernetes operator to switch off environment when you don't need it. The project, it's a project from Davide Bianchi. Davide Bianchi is a technical leader at Miaplatform, but Miaplatform support the project. We have another project, the name is Rotonde. The Rotonde, it's an authentication system, authorization system, sorry, for use it in your microservices without change any line of code. And the last one, I think, isn't the very perfect place to talk about it, but we have a micro front-end orchestrator. Maybe in your project you need it, and of course you can find it. About let me say the question, I think when we talk about platform engineering, we need to understand that isn't a project, it's like a path. Okay, and the people need to understand that no one can build stuff in a perfect way in just one iteration. Okay, you need to put in place small stuff, try it, ask to people, ask for feedbacks, and after that improve the existing functionality, and after a little bit add more functionalities. I think this is it's very important. Another important stuff is we talk about technology and innovation today, but we need to remember that every great revolution involves many people. We must remember to always put people at the center. For example, if you create a process around people, maybe you probably doing the right stuff. And if you are a manager, it's properly good also for your business. And I think it's the most important stuff to remember.
Absolutely, absolutely. Thank you very much, Mitch. And now I will switch gear to Rhea to let's rewind and recap and key takeaway for the listener who are listening to us today. Over to you now, Rhea.
Thank you, Simon. Yeah, so just in conclusion, I would like to say that platform engineering plays a vital role in modern software development by simplifying complex processes, streamlining workflows, empowering developers to focus on building rather than fixing. And we've discussed this in the entirety of the podcast. The use of an internal developer platform makes perfect sense because of its numerous advantages. By providing a tailor made solution of sorts, an internal platform ensures that features and functionalities align perfectly with the organization's unique requirements, leading to a more efficient development process, you could say. Additionally, it also enables customization and personalization in every aspect of the platform, promoting flexibility and adaptability as the business evolves and as they scale up. Moreover, the internal platform reduces your time to market significantly as it offers instant solutions from day zero and pre built tools, accelerating the application delivery itself. So, embracing platform engineering and adopting an internal developer platform not only enhances developer productivity, but also facilitates better collaboration. And, like we've discussed, and Mitch keeps mentioning, it's people first, product second. And so, having that collaboration between all your teams is an incredible facet of platform engineering. Also, it is cost effective and it gives you a competitive edge in today's fast paced technological landscape. So, in conclusion, that's what I would like to say about platform engineering as a whole.
Thank you very much, Ria, for the wonderful conclusion for the today's topic. So I will give you some of the resources for the listener or the watcher of the podcast. Is go to some of the resources and all these available on the YouTube chat. If you like to stay in touch with one of our speakers, so this is the link with to connect with Ria on the LinkedIn, and you can also connect with Michelle Morabito on LinkedIn as well, and also have a available on the Twitter, so you can actually grab the link from the YouTube description. I did a episode on how platform engineering, how did we get here? Like it's not a 1 day or 2 day. There's something happening, and then eventually talk about platform engineering. So Alexis Richardson, VWorks, and the co-founder of the Flux tool, is actually shared his opinion on episode number 81. And I did an episode on Backstage and Introduction to Platform Engineering on episode 70 on Martina Iglesias. And we talk about today success matrix. And there's a whole episode dedicated for that today as well. And there's a one very good founder and the innovator of this space, Dave Farley. And he's talk about some wonderful aspect to the platform engineering. Please do go and watch those as well. So all these resources available. This is from the GoTo conference, and some of the things we talk about DevOps, SRE, and platform engineering. This exist also. All the links available as well. Also the show notes and all the description and script available on the GitHub link as well. And during the episode, Mitch is talk about Cube Green, and I will be make sure to stay in touch with Mitch to have a dedicated workshop on another channel, and that another community I'm hosting that's called Cloud Native Islamabad. Do be available on there, because I will do some open source stuff with Mitch on that as well. But today we learned a lot from you, Mitch, and thank you very much for joining and describing and telling us the key concepts around what to consider for the build versus buy model. So let me conclude what I learned today. If you want to be if how to look at the platform, there's no one size fits all approach for platform engineering. It's boiled down to each organization's specific requirement, priorities, and what they want to accomplish via the platform. What are the how success of the platform team hides in effective collaboration, communication, leadership skills to guide teams, make strategic decisions, manage resources effectively, and drive project to success are the key skills that platform engineers should possess or adhering to. And what should a platform possesses? A platform should possess capabilities include, not limited to, standardized automation, consistent security policies, unified Kubernetes modern multi-tenancy, access management, or single administration pane, or just too simple is to simplify computing for the developer so they can actually work on the business need, not to fight with the infrastructure. But thank you very much, Mitch. We will stay in touch. Hope to cover again a Miaplatform in a hands-on dive. But this is episode number 1 with you. But I really enjoy the time. Hope you enjoyed too as well. Thank you very much. Stay safe, stay healthy. Have a wonderful day. Bye-bye. And we will meet
Thank
again soon.
you.